Hey guys, so previously we learned about the unit circle. I said that the unit circle is a circle that has a radius of 1 unit and it has a center point at the origin. So the coordinates of the center are 0, 0. We also learned that if we subtended that radius by an angle theta from the positive x-axis, the x-coordinate of any point on the unit circle is defined as the cosine of theta and the y-coordinate is defined as sine theta. We also learned that the tan of theta is the ratio between the y-coordinate and the x-coordinate. So that's just sine theta over cosine theta. So these are our three trigonometric functions: cosine theta, sine theta, and tan theta. Now in this video, we're going to learn about some of the common values of theta and the values that these trigonometric functions take for those values of theta. So let's say that we have an angle theta and that angle over here is just 0 degrees. So here theta is just 0 degrees or 0 radians, since the radius just lies on the positive x-axis. And here, the x-coordinate of the point on the unit circle is 1 and the y-coordinate is 0. So when theta is equal to 0 degrees or 0 radians, we can say that the cosine of theta is 1 and the sine of theta is 0. The x-coordinate is 1 and the y-coordinate is 0. And the ratio between the y and the x coordinate, so that's sine theta over cosine theta, is just tan theta is also equal to 0. Now the next value of theta that we're going to look at is when theta is equal to 30 degrees. Now 30 degrees over here, again, we've subtended the angle counterclockwise or anti-clockwise from the positive x-axis. So we have an angle of positive 30 degrees or pi over 6 radians, since we've learned that pi radians is 180 degrees and 30 degrees is just 1/6 of 180. We can say that 30 degrees is just pi over 6 radians. So when theta is equal to 30 degrees, the angle in radians can be written as pi over 6 radians. And the cosine of this angle is just the x-coordinate of the point on the unit circle, which over here comes out to square root of 3 over 2. And the y-coordinate on the unit circle comes out to 1 over 2. And the ratio of the y-coordinate and the x-coordinate, that is sine theta over cosine theta, is tan of theta, that is just 1 over root 3. The next value of theta that we're going to look at is when theta is equal to 45 degrees. Now when theta is 45 degrees, we can say that in radians, that's just pi over 4 radians, because 1/4 of 180 is 45. And over here, when theta is 45 degrees, again, you have a radius of just 1 unit. So the x-coordinate on the unit circle of the point on the unit circle is square root of 2 over 2. And the y-coordinate is also square root of 2 over 2. So we can say that when theta is 45 degrees, or it's pi over 4 radians, the cosine of theta is square root of 2 over 2. And the sine of theta is also square root of 2 over 2. And then the tan of theta is just the ratio between the sine and the cosine, which is just equal to 1. Now next we have when theta is equal to 60 degrees. Now when theta is equal to 60 degrees or pi over 3 radians, the x-coordinate of the point on the unit circle, that's cosine of theta, is 1 over 2, and the y-coordinate is square root of 3 over 2. So that's just sine of theta. So we can say that when theta is equal to 60 degrees or pi over 3 radians, the cosine of theta is 1 over 2 and the sine of theta is square root of 3 over 2. And the ratio between the y-coordinate and the x-coordinate, sine theta divided by cosine theta, is just square root of 3. So tan theta is equal to square root of 3.
Quick pause. If you're finding value in this explanation, there's so much more to discover. At Alt Academy, we break down every A-level concept with the same level of clarity. Now, let's continue.
Now the last value of theta that we're going to look at over here is when theta is equal to 90 degrees. Now when theta is equal to 90 degrees, we can see that the radius is perfectly vertical over here, and the x-coordinate of the point on the unit circle, since it lies on the y-axis, the x-coordinate is 0 and the y-coordinate is equal to 1. So we can say that when theta is equal to 90 degrees, which is just pi over 2 radians, the cosine of theta is equal to 0 and the sine of theta is equal to 1. Now the tan of theta over here, or tan of 90 degrees or tan of pi over 2 radians, is the sine of 90 divided by the cosine of 90. So if we do 1 divided by 0, well, we know we can't divide by 0. So we can say that the tan of 90 degrees or the tan of pi over 2 radians is an undefined value, over here. So now these are some of the common values of theta, the angle in degrees or in radians over here, and the associated values of the trigonometric functions for these values of theta. And these are some values that are very useful to remember and you're expected to reproduce. And an easy way to remember these values, is to use the following triangles. So here I have two triangles over here. The first triangle that we have is the equilateral triangle, where each side is of length 2 units. So here I have an equilateral triangle and each side is of length 2 units. Obviously the angles of this triangle are 60 degrees, right? Now if I divide this equilateral triangle into two equal halves, so I just drop a perpendicular from the vertex to the base, and I divide this equilateral triangle into two identical right angle triangles, what we have over here is this right angle triangle. We have a right angle triangle that has angles of 30 degrees, 60 degrees, and 90 degrees. Now, since we divided the base of this triangle into two equal halves when we drop this perpendicular bisector, we know that the base of the right angle triangle is 1 unit. The length of the hypotenuse is 2 units. So the height is just, we can find using Pythagoras' theorem, is just the square root of 2 squared minus 1 squared, which is the square root of 3. Now, knowing these values, we know that for a right angle triangle, if I wanted to know the cosine of 30 degrees over here, or pi over 6 radians, is just the side adjacent to this 30 degree angle, which is square root of 3, divided by the hypotenuse. So that's square root of 3 over 2. So the cosine of 30 degrees, or pi over 6 radians, is square root of 3 over 2. And the sine of this angle is the side opposite the angle divided by the hypotenuse. So that's just 1 over 2. And the tan of 30 degrees, or pi over 6 radians, is the side opposite divided by the side adjacent. So we have 1 over root 3. Similarly, if we wanted to figure out the values of the trigonometric functions when theta is equal to 60 degrees or pi over 3 radians, we can say that the cosine of 60 is the side adjacent divided by the hypotenuse. So that's 1 over 2. The sine of 60 is the side opposite, which is square root of 3 divided by the hypotenuse. So that's square root of 3 over 2. And then the tan of 60 degrees or pi over 3 radians is the side opposite, which is square root of 3 divided by the adjacent. So that's just square root of 3. So we can use this equilateral triangle. We can always draw this equilateral triangle to recall the values for cosine theta, sine theta, and tan theta when theta is equal to 30 degrees or 60 degrees, or pi over 6 radians or pi over 3 radians respectively. Similarly, we can use this triangle over here, the second triangle. This is the 45, 45, 90 triangle over here. And here the two sides that are perpendicular to each other are each of length 1 unit. So the hypotenuse is square root of 1 squared plus 1 squared. So that's square root of 2. And we know that the sine of 45 is just the opposite over the hypotenuse, and the cosine of 45 is the adjacent over the hypotenuse. So that's just 1 over square root of 2, which is the same as saying square root of 2 over 2. And the tan is just the opposite over the adjacent. So tan of 45 degrees or pi over 4 radians is just 1 divided by 1. So that's just 1. So we can use these two triangles, this right angle triangle over here, which we derive from the equilateral triangle, as well as this right angle triangle over here, to recall the values of cosine theta, sine theta, and tan theta when theta is equal to 30 degrees or pi over 6 radians, 45 degrees or pi over 4 radians, or 60 degrees or pi over 3 radians.
Now that that's taken care of, head over to our website to watch the rest of our A-Levels maths course. With 60,000 students trusting us, visit All Academy now and transform your A-Levels journey.